This is learning by doing. Today's lesson is Excel formulas and function. You will learn how to create and use formula. You will learn arithmetic operators and the order of precedence in performing this operator, and you will learn some built-in function in Excel, mainly math function. The example that you will do today is that you will estimate like hydraulic conductivity from a permeameter. Hydraulic conductivity, this is a useful property for if you want to estimate like groundwater resources and contamination, if you for many geotechnical applications. And this permeameter, you get your soil sample, you put it here, and then you measure the hydraulic conductivity of the sample. Before we start, let's just look at some like arithmetic operators. So for example, like you have like 2 to the power of 3, that should be 8. You have like 2 times 4, for example, or times 5, that should be like 10. You have like 30 divided by 5, that should be something like 6. And then you can do addition also, like you put like equal sign, 3 plus 5, that would be 8, and you can do subtraction. Okay, but if you combine like multiple operator, for example, like let's look at this example, like 15 plus 5 plus 10. So do we get like 15 plus 5, that's 20 times 10, 200. So do we get 200 or we get something else? No, we get something else. We get 65, because the order of precedence in these operators are as follows. First, it will do the power, then it will do the multiplication and division, then it will do the plus and the minus. So here it will start by first multiplying 5 times 10, that's like 50, and then it will do the addition, so that will be 65. If I want to do it the way it looks here, then I have to put like brackets. So I have to come and say here like open a bracket, 15 plus 5, and then so now it will sum these two, and then it will multiply by 10, then I get like 200. Similarly here I have a power, so it will not be like 4 times 3, that's 12, and then the power of 2, that's 144. No, it will be like first 3 times 2, that would be like 9 times 4, that would be 36. If I want it the other way around, then I basically come open a bracket like 4 times 3, then I raise it to the power of 2, then I get this one. Okay. Mass function and formula. So I can, like if I want to sum these numbers, one way I can do it is that I can come here and like this one plus this one plus this one plus this one. So I inserted the formula. Or I can use a built-in function, like a sum function. So that would be like sum. Okay. You sum them. Product, similarly, if I want to take the product of this number, I could come here like this one times this one times this one times this one, or I can just use the product function. So I come here like product, and then I select the range, and then it will give me. Similarly, average, I could take the write a formula for an average. So basically the formula for an average, that would be like the sum of this guy divided by the number of this guy. So the formula will be like sum. Again, like I'm using function inside my formula, and then like count of this guy. Okay, then I get this, or I can just take the average function. Similarly, if I want to take the geometric mean, I can write like this equation as I did here, or so here, that's how the equation looks like. Or I can just use the geometric mean functions. The harmonic mean, I can like use this equation, that's how it looks like. Or I can take a harmonic mean function. And it could be like, for example, like I can write this formula or this one, but it could be something complicated as like an error function, for example. So I don't want to solve this, so I just take an error function. So like an error function of 1, like somewhere here, you get like an 8.4, which is something what you get. You can take like the remainder. For example, if I want to divide like 23 by 5, what's the remainder? So the remainder would be 3. I can take the quotients as like the opposite. Like if I want to divide 23 by 5, what is the integers that I get? Like ignore all the decimal and give me the integer. So the integer will be here 4. Sealing, for example, I want to seal this number to, so like you see the sealing here, when it comes, it tells you like what is the number that you want to seal, like 1.12, and what is like the significance. So the significant digits like 2. So I want to seal it like the top of this one, so that would be like 2. For example, I want to floor like 1.2, that's like the opposite of sealing. So sealing go like to the top, floor go to the down. Round, so I want to round this with like one significant digit. I want to round it up, round it down. I want to take the radian, so I have an angle 30 in degree. What's the radian of this one? Vice versa, if I have this angle in radian, what would be in degree? If I want to take sine, so basically sine angle 30, so I take the radian of angle 30, then I take the sine function. If I want to take like an inverse sine function, so basically I take the like this value here, for example, like, and then I take it in degrees, so that would be like 30 cosine 10 by exponent len log function. If I put log here, so this log function is very general, so it just tells you like the number and the base. If you didn't put the base, it will assume that the base is 10. If you want to be specific and just specify that this is to the base 10, then you just use the formula log 10. If you want to take the natural log, this would be the length, for example. Power, to the number and to the power. Or I could just like take the power, you know, as like a formula. So here like 10 to the power 2, for example. I can generate a random number. I can generate a random number between like 7 and 19, like any range that I want, like a random number between 1 and 5, for example. So I should get here something from 1 to 5, like 3, okay? I could generate like a random number from a normal distribution. You come like, this is like a random number, you specify the mean of the normal distribution and like the standard deviation, let's say 1, for example, then you generate. Okay, so let's go to our example. So in our example here, I want to estimate hydraulic conductivity. I want to the lab, I have 12 soil samples. You have, this is what is unknown, the sample length, so that's like something here, like this length. Initial head, so that's like when I started like the experiment, so the head was here, and then after certain amount of time, which is 30 seconds here, I count like the head, like how much the head will fall like from here to here, for example. Then I see like the final head here, and that would be, that's like the variable, and based on this one you will know the hydraulic conductivity of the sample inside diameter of the falling head tube, like the diameter of this tube, and inside diameter of the sample chamber, like this diameter here. Okay, and you get this value, you substitute into this equation. So let's do it. So you come here, you have like dt squared, so that's like dt, like this one, and then I square it, and then you multiply this by L, so that would be this guy here, and then you multiply this by len, and you have like the h node divided by, so that's the variable one, like h, that should be like g2, okay? And then you divide, like, now here you need to open a bracket, because you don't want to like divide by this and then multiply by this, you want to divide by all these guys. So basically what you do here, so you need this bracket, you get this, and you raise it to the power of 2, and then you multiply it by the time here, okay? And then I got something like this. So here, if I drag this, it will do automatic filling, but I need these things to be constant. That's a constant, that's a constant, that's a constant. So I need to remember from the previous lesson how to do absolute reference. So just put this dollar sign. G2, that's not constant, so I don't put a dollar sign here for this guy. So I put a dollar sign here because that's the one that's variable. And then double click here, it will automatically fill them for me. I want to take the natural log of this guy, so I take like len, and put here, fill it for them. Now I want to take the arithmetic mean, so that's like simple average function. Okay, so you click here. I want to take the geometric mean, so that's like the geomean function for these samples. Okay, and then I want to take the harmonic mean, so that's like the harm mean. So very simple set of, I think then now you get the harmonic mean. So I did all this. Now plot the histogram of k for len k for all sample using 5 pins. So I want to just like basically, okay, you see here the harmonic means that's the smallest value because the mean is the central tendency. So that's like the, for example, like the central tendency. So the flow here would be like this slow, here would be the slowest, it would be a little bit faster. The harmonic mean, it would mainly be dominated by like because that's like, you can think of it like the bottleneck flow. So that would be like the small value. So that would be smaller than the arithmetic mean. Okay. Let's do the last part, like plot a histogram. So the linking. So I come here to this guy. You go to insert. I want to insert a chart. You go to like a histogram. So I have a histogram. Here it make it like 3 pins, so it divides them into like 3 categories. Now I wanted to make it like 5 categories. So like you click on the chart, you format data series. Oh, here, this is basically something else. Like here, I'm just like putting a gap between this so that they would look better. But here you select you select the axis, format axis, and then the number of pins, I want to change this to 5, so 5 groups. Okay, so now I have like this into like 5 groups. I can make my chart look better. Like I can add a title, for example. I can say histogram of length k. I can add here like something, so you can add, you go to design, add a chart element. I want to add a title, so I add a primary X title, and let's do another one, vertical title. So the vertical title, that's like the frequency, and this title will frequency, and this title will be len k. So basically, it tells you like within this class from negative 9.1 to 7.6, you have 1 sample. In this class, you have 1 sample. In this class, you have 1 sample. In this class, you have like 3 sample, and in this class, you have 5 samples. So you know like something about the frequency. That's it for today's lesson. And see you in the next lesson.